Hi, this is Rock. We're going to look at ifs. This is a function that helps you delineate into different categories based on what usually is a numerical question. At least from my perspective, ifs is better for calculations than switch. And other than that, they're pretty similar. So we'll cover switch when we get there, but ifs is a formula that looks like this. If I start to type it and put it in here, it's looking for a logical test, and then you need to provide what if that test is true. And then you can continue to provide logical tests as pairs of if it's true, then this. If the other thing is true, then that. So let's use the periodic table of the elements to create an ifs statement. Over here I have information about atomic weights from the IUPAC Commission on Isotopic Abundances and Atomic Weights, and also a periodic table from Wikipedia. This list has the elements in numeric order, and if you look at the periodic table, how this corresponds is you see this 1 here, 2, 3, 4, 5, 6, etc. correspond to this number over here, the atomic number. What we're going to use is the atomic weight, but what we're going to want to do with this ifs statement is see these rows in the periodic table. They go 1 through 7. What I want to do is show you how the if statement can be very helpful in this situation. Let's say this is going to be period row. So what we're wanting to determine is what row does this element go into just based on this atomic weight. So we're going to put together an ifs statement. So ifs is like if, but instead of just having one outcome, you can have multiple and multiple logics. So here we go. The first logical test I can say here is if the weight is less than 4.0026. I'm going to use these weights for the noble gases on the right as the indicator that if it's less than or equal to that, then include it in that row. In order to do that, I'm going to want to call out where these are. And to do that, I can just copy the ones that are on the end over here. We can say end element, weight, and that's going to be helium. I'll put that there. We're going to go with neon next, and argon, krypton, xenon, radon. And as you can see here, this green area fits into there. So all of these on the top of this bottom one are row 6, and all of these on this bottom row of this bottom section are row 7. Oganesson is 118, and that's down here. Okay, so now what we're going to do is be able to use that in our formula. So we can say ifs this is less than or equal to this. And I'm going to need to make that an absolute reference because I don't want it to change as I copy this down to the different rows. Then it's 1, row 1. All right. Now for my next logical, I'm going to do what I usually do with this kind of thing, and I'm going to put it onto a new row by holding Alt and pressing Enter. Now I'm going to do the next logical. If O10 is less than or equal to P19, then 2. Here's something to know about ifs. Because it executes the first thing first, and if it matches, it'll go here before it goes to the next logical. You can use that to avoid having to say if O10 is greater than P11 and less than or equal to P19. You can avoid that because that question has already been asked in the first logical. It's executing it from the beginning. Now I can just copy this, and we've got 7. So I'm going to say that's for 3, 4, 5, 6, and 7. And we'll change all these so that it's the right number. We'll say 3, 4, 5, and 6. And then instead of P19, we'll say P27. make that absolute. P45, P63, P95, and for this last one, it's P127. All right, let's try this out. So that says row 1. If I paste this down, how does it play out? It changes to 2 here, and it changes to 3 on sodium, which is what we wanted. And if I paste this all the way down, it's 7 between radon, or francium. It starts row 7, francium through oganesson, which is correct. But that is how the ifs statement works. So next we'll look at SUMIF and SUMIFs. See you then.